Okay, so what we're looking at here, here's the original function that was in the problem right here, and then your partial derivatives are right there. So what I'm going to do is just go through and double check because there's a few mistakes. I believe this one here is the partial of m with respect to c, and then the second one is the partial of m with respect to f. That's the worst partial ever. There we go. So here we go. Looking at the first one here, partial of m with respect to c. So first term, there are no c's, it's just an 11, so it's 0. Second term, there's a c to the first, so we're going to bring that out to the front, which would give us, let me make some room here. So that's going to give me 1 times 8c to the 0. Anything to the 0 is always 1, so it just leaves me with 8, like you had. Perfect. Then the next term right here would be c squared, so the 2 comes out to the front, making it 2 times 4c to the first, so that would give us 8c. So 8c. You only had 4c, so we just need to check that. Then next term, that's no c's, so it's just 0. Next term, we have a c to the first, so that's going to come out to the front, making it minus 1 times 20 c to the 0 f. Well, anything to 0 is always 1, so that makes it minus 20 f. And you only had negative 2f. I'm wondering if that was a typo, and you meant to put 20f. So there's the first partial. The other partial, partial of m with respect to f. Let me clear out my work. Okay, so now we're going to do the partial of m with respect to f. So first term, no f's, so that's 0. Second term, no f's, 0. Third term, no f's, 0. Fourth term, f to the first comes out to the front, negative 1 times 40f. I just realized I switched, it's right, but I just switched the notation. I did it the other way. So negative 1 times 40f to the 0, anything to 0 is 1, so it leaves me with negative 40, just like you had. So now, the next term would be f to the first, the 1 comes down to the front, making it negative 1 times 20c, and then f to the 0, anything to 0 is always 1, so that just leaves me with negative 20c. You only had negative 2c. Again, wonder if that was a typo, and you meant to type 20, but there you go. So then for the last term, I'm just going to need some space, so I'm going to go this way. Alright, so now here, for the last one, it's f squared, so the 2 comes out to the front, making it 2 times 40f to the first, so that would give me plus 80f. That's what you have right there. So here are our partials. So my guess is that could have been what was causing a mistake, is if you truly made mistakes on those partials. If not, I'm still going to kind of walk through the rest of the problem anyway, just so it's done. Okay, so first thing first, let's finish up this problem. So first things first, we're looking for critical points. So we want to find the maxes, mins, and saddles of this m function. So to do that, we take the partials. Okay. Why? Because we want to know the rate of change. We want to know where that rate of change is equal to 0. Because then if we're at 0, we're either at a max, a min, or a saddle. So now we ask ourselves, how do I solve this? And there's lots of methods. Don't lose sight of the entire purpose of Chapter 2. Do we want to use substitution technique? Do we want to use elimination technique? If it's linear, can we just throw it into a graphing calculator and let it do reduced echelon form for us? So here what I hope you see is, look, everything's linear. So I'm just going to put it in a form so the graphing calculator can just pop it out. So this equation would become 8c minus 20f equals negative 8. The second equation would become negative 20c plus 80f equals 40. So now I take those, put them into my handy dandy little calculator. Okay, so we're going to put in the calculator, and it's going to be 8, negative 20, negative 8, negative 20, 80, 40. And note, this whole row 2 is divisible by, or multiplied by 1/20th, and we can simplify the numbers, make them a little smaller. But since the calculator is doing the work for me, I'm not going to worry about it anyway. And we end up getting something of the form 1001, and the answer is, let me check. Yeah, so the answer is 2/3, 2/3. So we have 2/3, 2/3, and don't forget how to read it. And remember, this column was C, this column was our F. So that means C equals 2/3, F equals 2/3. And now we just go back and apply that to the context in the problem. Whatever C stood for, whatever F stood for, and work from there. Okay, now that we've found C and F, we need to use those to solve for M. So we're going to go back to our original equation up here, and everywhere we have a C and an F, we're going to replace it with 2/3 right there, 2/3, so on and so forth. We'll pop all those in, find out what M is, and I'm not going to worry about that for now. I'll let you do that part. But the next big piece is saying, okay, so we have some critical point at 2/3, some number, but what is it? Max, min, saddle? I don't know. So how do we check that? Well, that's where the d-test comes in. So the d-test, the x and y values of our critical point. So we're going to use 2/3 and 2/3, and that's equal to f of xx, not f of xx, excuse me, the second partial derivative with respect to x, the second partial derivative with respect to y, minus the partial with respect to x and y squared. So we need to find those second partial derivatives. So we already did the first ones up here. So remember this first one right here, whoops, that was the partial, this one was the partial of m, not f, partial of m with respect to c. So down here we don't have x's and y's, we have c's and f's. So c, f, so here this would be C and F. So then here for the equation, we're going to do second partial with respect to CC and second partial with respect to FF, but it's not a function of M. Excuse me, it's a function. Sorry, not a function of F. It's a function of M. So M with second with C, F, M second partial with respect to F, and then here we need M with respect to C and F. Okay, so now that's with respect to C, so now we need to do it again. We need the partial, second partial, and actually what I'll do, I'm going to give myself a little more space here. So here, I'm just going to shrink this down, give myself some space to work with. Alright, so now, I need second partial of M with respect to C. So, just, again, this whole derivative, but with respect to C. Well, that's no C's. That one, just an 8. This one, no C's. So the second is 8. Similarly, let me give myself some space right in here. Right, I'm gonna have to cut my 0 kind of in part here. Let's see how that all works. So let's see what happens here if I try that. Oh, didn't quite go as planned, but I don't need this stuff anymore. So now this right here was really the partial of M with respect to F. So now I need the second partial of M with respect to F. So going through here, no F's, no F's, there's an F, 80. So these are kind of really nice because it's just 8 and 80. Then last but not least, I need the, and I'll kind of do this in a different color, I need my interaction term. So I need the partial of M with respect to C and with respect to F. And how I can get that is by using, maybe let's say this first one. I'll use it. Remember, the order doesn't matter. That's equal to the second partial of M with respect to F, then with respect to C. So I just need to use either one of my first partials and then take the derivative of it with respect to the other variable. So I'll use this one here. Since I already did it with respect to F, now I need to do it with respect to C. So no F's, sorry, no C's, no C's, so I'm just left with this middle term. So this would be equal to negative 20. So now I'm going to take all three of my partial derivatives, my first one being 8, my second one being 80, and my third one being negative 20, and kind of fill them into this equation. So d of 2/3 is equal to the CC I believe was 8. Let me go up here and double check that. 8, yes. 8. FF was 80 minus negative 20 squared. So my third one was negative 20. So now the question is, well, first of all, look at your concavities. This one is concave up. The second one is concave up. So right now, they both look like they are minimums. So the only question is this a big enough negative, once I square this, is this going to be a big enough number to drag me down into the negatives? So here we go. All right, so, well, 8 times 80 is 640. And again, we don't really care about the actual number. We just need to know if it stays positive or if this is going to be big enough to bring us down to the negatives. So negative 20 times negative 20, well, that makes a positive, but positive plus a negative makes a negative, because you see we already have the minus sign right there. So what we're going to worry about here is what's 20 times 20? Well, that's 400. So this is going to end up giving us a positive 240, which means we are still greater than 0, which means we are still, as before, as we said, this part right here, concave up, other one's concave up, so they're mins. So therefore, this point right here is a minimum. We have a minimum of whatever that number happens to be when you substitute in 2/3, 2/3. So we have a minimum of blah at 2/3, 2/3. There we go. Hope that helps.